Good day, students. On this clip, we're going to be going over an example on how to find the equation of a tangent line and even a normal line for an equation that's written in implicit form. Okay, so let's write down the instructions for the question. It's number one, find the equation of the tangent line to the curve x squared plus y squared minus 2x plus 4y equals 8 at uh, 4, 0. Also, find the equation of the normal line, of the normal line. Okay, so we're going to be looking for two things here: the equation of the tangent line and the normal line. So in order to write down the equation of the line, we have just a point. We're going to be using the formula y minus y1 equals mx minus x1. This is the point form to help us find the equation of the tangent line. So this is for the tangent line. And then for the normal line, we just need to find the inverse of the slope. So we use the equation y minus y1 equals negative 1 over m x minus x1. So basically, the negative reciprocal of the slope of the tangent line will help you determine the slope. That will help you find the equation of the normal line. Okay. So since we don't have 2 points, we have only 1 point, and we need to find the slope because we already know what the point is because we have the point 4, 0. And we know that x1 is 4 and y1 is 0. So all we need is m, and then we're good to go. So the tool that can help us find the slope at just a point is the derivative. So that's basically the power of the derivative. It enables us to find the slope of a curve with just 1 point. Okay? So all we just need to find is the derivative of this function, and then we'll evaluate the derivative at this point, and that will tell us what m is. All right? So since this is an implicitly defined function, we need to differentiate using implicit differentiation. All right? So we have x squared plus y squared minus 2x plus 4y equals 8. So let's go ahead and look for dy dx. So differentiating implicitly, we apply the power rule here. The derivative of that will give us 2x dx. We differentiate in respect to x. Plus differentiate that, we have 2y dy dx. Minus, if you differentiate 2, you have 2 dx. And then if you differentiate 4y, you have 4 dy dx. And that whole thing. And then if you differentiate 8 using the constant rule, you end up with 0. Alright? So let's simplify further. This is just 1, so we have 2x plus 2y dy dx minus, this reduces to just 1, so we have minus 2 plus 4 dy dx. Okay? Equals 0. Alright, now we're going to move the terms without dy dx to the other side of the equation, and then combine, and then bring the dy dx's together. So we have 2y dy dx plus 4 dy dx. And if I subtract 2x and add 2 to both sides of the equation, I'll have negative 2x plus 2. Okay? Now to isolate dy dx, I'll just factor dy dx from these two terms. So I'll have 2y plus 4 dy dx equals negative 2x plus 2. Alright, so to get dy dx by itself, I'll divide both sides by 2y plus 4. So that will give me dy dx equals negative 2x plus 2 divided by 2y plus 4. Okay? So what does this help me determine? This equation right here, dy dx equals negative 2x plus 2 over 2y plus 4, it helps me find the slope this curve at any defined point xy. Okay, so basically m at xy, slope of the curve at xy is given by this function negative 2x plus 2 over 2y plus 4. So if I want to determine the slope at any point, all I just need is my x and my y values, and I'll substitute them into this function, and it basically generates the slope for me. Okay? So we know from the problem that x and y, the point that we're given was 4 and 0, right? Those are the points that we were asked to calculate um, the slope of the tangent line at. So that's what we're looking at. So x is 4 and y is 0. So what we're going to do is we're going to evaluate the slope at the point 4, 0. So basically we'll substitute 4 for the x's and 0 for the y's in this differentiation on the slope formula to determine the slope. Okay, so we're going to have negative 2 times 4 plus 2 divided by 2 times 0 plus 4. Okay, so what did I just do here? I just substituted 4 for the x and 0 for the y in this function that I derived by differentiation. Okay, if I simplify this using the order of operations, I'll have negative 8 plus 2 over 4, and that becomes negative 6 over 4, and it reduces to negative 3 over 2. Okay, so basically the slope of the curve, the slope of the tangent line, of the tangent to the curve at the point 4, 0 is what? Is negative 3 over 2. Okay, so that's the slope of the tangent line to the curve at that point. Alright, so let's write out the equation of the tangent line. So to write an equation of the tangent line, I'm going to use the formula y minus y1 equals mx minus x1. Okay, remember that x1 is 4, y1 is 0 because of this point, and the slope at that point we already computed is negative 3 over 2. Alright, so plugging these ingredients into this equation, we're going to have the function, the equation y minus 0 equals negative 3 over 2 times x minus 4 times x minus 4. Alright, so there goes your equation. Let's just simplify it a bit. So we have y equals negative 3 over 2 x minus 4. This is the equation of the tangent line, okay? Alright, now let's go ahead and determine the equation of the normal line, okay? So all we just need to do here is basically find the inverse of the slope of the tangent line, right? So just a minute. Alright, so slope of the normal line, m of normal line, is basically equal to the negative reciprocal of the slope of the tangent line, alright? Negative 1 over 1 over negative 3 over 2. If you simplify that, you have negative 1 times multiplied by the reciprocal, which is negative 2/3, which is equal to 2/3. Okay, so that's the slope of the normal. So if we want to write down the equation of the normal line, we'll have y minus y. We're going to use the same equation, equals 1 over m x minus x1, where m is the slope of the tangent line. So we already calculated what this is. So we're going to have y minus y1, still the same y1, which is 0, equals negative 1 over m of the tangent is 2/3, we calculated it here, times x minus 4. Okay, that's x1. Simplify this, we have y equals 2/3 x minus 4. Okay, so this is the equation of the normal line. Alright, okay, so now what I'm going to do, I'm going to show you the graphical representation of the solution we just got. And then just basically see if we can draw a connection between these equations, the terminologies, and what the graph looks like. Okay, so let's say that we have the following function. We're going to try and graph the function. All right, so this is the original function that we are asked to graph, x squared plus 2 plus y squared minus 2x plus 4y equals 8 as a graph. This is a graph right here, as you can see. It's a graph of a circle. If we completed this square, you get to see that it's actually the graph of the circle. All right, so if we insert the equation of the uh, tangent line that we just computed, let me generate the graph for you using my computer. You can see that at the point 40, this line is tangent to the curve. Okay, and then the normal line, let's see what the normal line is. All right, there goes your normal line. Okay. All right, so now what we're going to do is we're going to basically write down some equations to help us see the connection between all the components. All right, so let's just label it real quick so that you can really understand what's going on here. So basically this piece right here, this is the function, the original implicitly defined function that we differentiated, which is x squared plus y squared minus 2x plus 4y equals 8. This is a point of evaluation. This is a point 40. And if you take a look at this line right here, the line in black, this is the tangent line. Okay, the tangent line. And it has the equation y equals negative 3 over 2 x minus 4. Okay, we can see this tangent line right here touches the point at exactly 0 4. We see how it's tangent to the curve. All right, and then this other line right here, this is your normal line. Okay, we see how it's perpendicular to the tangent line. That's what the normal line is. It's perpendicular to the tangent line. Okay, so this is a normal line, and the equation we determined was y equals 2/3 x minus 4. Okay, so I generated this graph using the graphing software, so we can see how accurate our curves are, showing us what the tangent and the normal line of an implicitly defined function looks like. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel and share this video with your friends via Facebook or Twitter. More videos can be found on mathroomself.com. Thanks again and have a wonderful day.